So hello everybody, my name is What You Do Care, and in this video we shall be solving the fourth question of the Harvard MIT Maths Tournament, which was held in spring 2021, and this is the fourth question of the Algebra and Number Theory round, which was held in 6th March 2021 in MIT. Okay, it was actually held online because of the coronavirus pandemic. Alright, so now we need to solve this equation. We need to solve this question actually. This question is having 4 points which we need to consider. The first point is that we are basically given a 3 variable function px comma y comma z, and it has also been given to us that the degree of this 3 variable function is 4 and it is homogeneous. Now those fuckers from you who don't know what is homogeneous function is, let me put you in context. Any function is homogeneous of the type is being given to us if we're basically having anything as p, x, y, z. Okay, if we substitute any real number k in place of x as kx, similarly if we replace that same number k in terms of ky, and similarly if we replace kz to z, the function pxyz will be called as a homogeneous function of degree 4 if this thing can be expressed in the form of this. If this is possible, then the function is homogeneous and the degree is 4. So pxyz is a 3 variable function and it is also a homogeneous function of degree 4, which means that if xyz is replaced with kx, ky, kz, then it needs to be represented, or it must be in this form. It must satisfy this form for each and every value of k belongs to real numbers. So this was the first point corresponding to this question. The second point is saying that this 3 variable homogeneous function of degree 4 is satisfying the 3 variable commutative property, which means that PABC will be equal to PBCA for each ABC belongs to real numbers. Okay, this was the second point. It was easy to understand. The first point is simply saying for each and every ABC belongs to real numbers, this 3 degree homogeneous function of commutative nature of degree 4 will going to satisfy PAAB always as 0. Okay. The fourth point is given that if P123 is 1, the question is we need to calculate the value of P248. Okay, this question seems interesting, but this question is, yeah, amazing. Okay, obviously it is Harvard and MIT Maths Tournament. What other thing you can expect from them? So let us solve this question. Now, we will going to go point by point, and we will try to create a function pxyz that will going to satisfy all these 4 points. Then we just need to put the value 248 in our created function, which has satisfied these 4 points. Simply put and evaluate the answer. And we also need to take into our concern that the answer for all the questions which are asked in HM square t is always a positive natural number in between 0 to 10,000, or you can simply say that answer must be a natural number. Okay, so let's go. The first point is that the function is 3 variabled, which means it has 3 variables which are x, y, and z, and it is having a degree 4, which also we need to take into our concern. It is having a degree 4, which means that each term of it must have a degree 4, or the highest term degree is 4. And it is homogeneous. Okay, it is homogeneous. Nice. In that case, let us suppose that pxyz is something alpha x to the power of 1 y to the power of 1 z square. In this case, the degree is 4 and the function is homogeneous and the function is of 3 variables x, y, z, so it is satisfied. Plus beta x y squared z plus pi x square y z. Now let us write the characteristics of this function. All the characteristics which we will basically going to investigate here will going to be in the form of representation. Where is my highlighter? So here, what are the characteristics of this function? First of all, here this alpha is a constant. Okay, this beta is also a constant, and this pi here is also constant. Okay, you fuckers, please don't misunderstand pi here as 3.14. It is not that. Okay, I have created this as a variable. I've used all the Greek letters alpha, beta and pi, or the Greek alphabets. Now first thing first, this function pxyz is having three variables, which are x, y and z. Okay, so this property is satisfied. Second thing, each term is having the total power of 4. You can see that x to the power of 1, y to the power of 1, z to the power of 2. So the sum of the powers of x, y, z is 4. Similarly, in the beta term, the sum of the powers of x, y, and z is also 4. Similarly, in the pi term, the sum of the powers of x, y, z is 4. So our second characteristic here is that it is a function of degree 4. So this thing is also stratified. Now how to check it is a homogeneous function or not? We just need to replace x, y and z with something kx, ky and kz, and let us see what happens. X will be replaced with kx, y will be replaced with ky, z will be replaced with kz square, plus beta, x will be replaced with kx, y will be replaced with ky to the whole square, and z will be replaced with kz, plus pi, x will be replaced with kx to the whole square, y will be replaced with ky, and z will be replaced with kz here in this case. Here f of kx, ky, kz will basically going to support the form here as alpha of we just need to take all the k's out. The total k's are k to the power of 4, 1, 2, 3 and 4. It will going to be alpha x y z square plus beta x y squared z plus pi x square y z. So we can basically write this function as in the form this. So yeah, this is also a homogeneous function. From here, the third property characterizing this type of a function is that it is homogeneous. It is a homogeneous function. It is a homogeneous function of degree 4 as been here. Okay, so this was the first property, this is the second property, and this is actually the third property being associated to us. Now we also need to talk about the fact that why I have taken only x, y, z connected terms. I can also take x cube terms or x square, y square terms. So why I have taken only this term? Actually, yeah, you are right. If you are thinking this, why I have not taken x 4 term, y 4 term, or x square, y square term. That can also make the function homogeneous, 3 variabled, and it is also valid. But I just need a value, in more specific words, I would like to say that I just need only one type of a function. I do not want to create a generalized system of function here. I just need to calculate the value of this thing. So I've taken only one of the types of that possibilities. Okay, yeah, you are right. If you can do it some other way in order to satisfy these three properties, I'm doing in this way. I'm not saying that this is the only representative way of pxyz. There are also other representative ways through which you can represent pxyz so that it can satisfy these three properties of homogeneity, three variability, and degreeization of quadruples. Okay, my main concern and my chief concern is just to evaluate the value of P2 for it through a function which we're going to satisfy all these 4 points, for which a potential function is this one. It is not the only one which you can do. You can do it some other way, but the key point of me for this function is to make things easier and to make each and every term identical, because each one of them is having xyz, so they are seen as an optical term to each other that can make this question more sexier to evaluate. See, mathematics is all about patterns and beauty and implementation of logic in a very good way, and I am trying my best to do that here. Okay, and I'm also speaking so much English right now that if this much amount of English I will be speaking in front of my crush in my school, then probably I will not be single right now. But okay, never mind. It's just a mathematical thing in which I'm just fascinated into in speaking this much amount. Let's proceed into sustaining more points of this question. So right now we have just proved the tetrahedral homogeneity of this three variable function pxyz here. Now we will going to move ahead and try to also satisfy this function to the commutativity property. We now need to modify this alpha, beta, and pi such that our generated function also satisfy the commutativity, which also needs to be satisfied, which is the second condition here. Okay, so let us do that. We are going slow, but we are going in detail. That's my chief concern. You can take the time, but you need to understand each and every part of step. So here, this function needs to satisfy P, A, B, C is equals to P, B, C, and A here. This needs to satisfy this thing here right now. Now here, what we can do is we just need to put the value. We can simply put these things in our terms. It will going to be in the form like alpha A B C square plus beta A B square C plus pi A square B C. It will be equal to alpha B C A square plus beta B C square A plus pi B square C A. Interesting. Actually, here if we cancel all the ABCs which we can see, we would basically going to be getting this phi B plus pi A equals to alpha A plus beta C plus pi B. If you're basically going to divide this whole thing by ABC and so do the right hand side, if you will basically going to divide the whole thing by ABC. So you're basically going to get the next step by dividing both the sides with ABC. Got it. Now moving ahead, we need to substitute the values of alpha, beta and pi, because ABC can be any real numbers. So we would basically going to make the terms here. A alpha minus pi plus B pi minus beta plus C beta minus alpha, it needs to be equal to 0. Okay, this needs to be clear in your mind. Right, so now we know that a, b and c can be any real numbers, and each and every time all the different values of a, b, c which we will going to choose, this expression should always have value 0. This can only be possible if this individual values are 0, because individually if beta minus alpha, pi minus beta or alpha minus pi are 0, then obviously any combination of the triplet value of a, b, c will going to result every time the value of 0, which is our main concern, which is the main thing which this equation is telling to do, that it must always be 0, which it is, even only if and only if these three things are 0 simultaneously. So here it is indicating that alpha must be equal to pi, here it is indicating that pi must be equal to beta, and here it is indicating beta must be equal to alpha. And since these three needs to be done simultaneously, from here we can simply say that pi is equals to beta is equals to alpha. So if this thing is satisfied, then our function, this one, is also commutative. And let us suppose that all of them are equal to k, which is another real number. Okay, then we can write p x y z as k times of x y z x plus y plus z. So in this way we have also satisfied the commutative property associated with this function. So this is also satisfied right now. But the main problem now is with this thing. This will not going to satisfy it actually. If this is a function and this function needs to satisfy our third condition, then it cannot. It will only if k is 0. But if k is 0, then it will not be able to satisfy the fourth property. So here we are stuck. We cannot proceed with this thing. We need to introduce another term in pxyz in order to save us from this contradiction which it has been created. And so we cannot move ahead actually. This thing will not going to work actually. Basically here this needs to be satisfied only when this is divisible by x minus y. But if it is divisible by x minus y, then it will not going to be commutative actually. Now here we are struck out. We're gonna proceed further through this. What we can do is that what we can do is basically here we first let us modify p x y z to satisfy the third property. Okay, then we will going to satisfy our commutative property, because the third property satisfaction is extremely important. Okay, so for third property to be satisfied, it is simple that in this case this thing needs to be divisible with x minus y. So this whole thing needs to be divisible with x minus y, and in such a manner that it also needs to be commutative simultaneously and also homogeneous. So p a b in this case here, guys, it will basically going to be a square b square plus beta a times a square is a cube times of b plus pi, it is simply a cube b. Moving ahead, Moving furthermore in this case of consideration, we can basically factor out a square and a b, and things will basically going to turn out as alpha times a plus beta times a plus pi times a. It is strange, and it needs to be equal to 0. Nice. Although I have not expected this to happen. It's like, what the fuck? So it will be like a square b multiplied with a times of alpha plus beta I've taken this needs, yeah, this is actually b. Oh yes, that's why Uh, so it is actually a beta plus pi plus alpha b. This needs to be 0 always. So this needs to be 0, and alpha needs to be 0. So alpha needs to be 0 and beta plus pi needs to be 0 for the function pxyz to satisfy the third property. Now writing this pxyz again with the new modification of satisfying our third property, that PAAB will always going to be 0. In that case, load, we can simply write here as our answer as alpha is 0. We have considered it. We will going to leave beta as beta only. It will simply going to be b times of x y square z, and pi is actually negative beta multiplied with x square y z. It will basically going to be now p of x comma y comma z. It will be equal to beta times of x y z multiplied with y minus x. Oh, it is interesting. Nice. So the third property is always satisfied, but it's still a case of wonder actually. In this case of consideration, now this function needs to satisfy the commutative property here, which is a bit of tough, because if it needs to satisfy PABC is equals to PBCA, beta needs to be 0. So here we are stuck. I do think so. If we need to save us from this contradiction, I need to introduce another type of dilemma here. Here, if p x y z is now equals to beta x y z into y minus x, currently it is satisfying this property of PAAB 0, it is satisfying homogeneity of degree 4, it is satisfying, it is having 3 variables. And we can simply let b take a value so that it will also going to satisfy p1, 2, 3 equals to 1. The only problem is that it needs to satisfy this commutativity in a way. This, if we can do, the question is done. Now I need to think now how we can achieve that thing without losing the pre-existing success of achieving the dominance of us on these properties. We also do not want to lose these things when we will basically going to create one. Okay. So a clever way of doing this, I do think that we can introduce another. function like this, it is also 0 at PAAB. But since A and B are real numbers, I cannot introduce them because they can take any possible values if it is y minus x. So let us suppose that I substitute another function having a scalar value k multiplied with y minus x, because also it needs to satisfy this thing. It also needs to satisfy 3 variability and homogeneity. So to satisfy homogeneity, which is actually pretty easy, we can simply write x cube here. So we can simply write x cube. So this is our new function of p, x, y, z. It is also satisfying 3 variability, it is satisfying homogeneity, it is satisfying the fact that p, a, b is 0. Okay, and we just need to take this in a way that it also satisfies the commutative property. Okay, but what do we do with this constant k? We can also take it as b if we wish to. If we wish to, we can do that. Yeah, you can take any homogeneous function. You can take x square y, you can take y cube or z cube. You just need a function with this having a power of 3 above. Either a singular function or more variable, but summing the power must always be 3. You just need to take this into your concern. Now we need to put ABCA and BCA in these two shit, and we just need to compare them. It will going to be BABC times of B minus A plus K times of B minus A times of A cube. It is equals to the fact that it is basically PBCA. So it will still be ABC, nothing extra. Now this will basically going to be B minus C, I do think so, because yeah, B minus C right now, plus K times of B minus C times of X cube or B cube. Wow. Things are going on a flow, I suppose. B minus C, B minus C, C minus A. Okay, in this case. Now what we can do is that we can eliminate A. I can see the elimination of it. No, I cannot eliminate A in this case. No, I'm sorry, cannot. So it is B times of A, B square C minus beta A square BC plus K times of A cube B minus K times of A4 equals to beta times of A B square C minus beta times of A B C square plus K times of BC cube minus K times of B cube C. I know that you cannot see what I'm doing right now because the screen can only take up to here, but you can do it. I know what you also know that what I am doing right now. But I know that nobody's watching this video. I only watch myself to satisfy my loneliness here. I can write this as beta times of ABC times of B minus A minus B plus C, which is equals to K times of B4 minus CB cube minus A cube B minus plus A4. Okay, we need to take this into our consideration. This and this can simply cancel each other out. It will going to be beta ABC c minus a equals to k times of a to the power of 4 plus b to the power of 4 minus b times of a cube plus cb square, motherfucker. Now here k takes the deal. If k and beta are equal, then now as I can choose any value of k, so I can choose any value. It is as simple as that. I can choose 2, I can choose 3. It is inside my consideration. I'm going to choose its value as 1. So it will going to be 1. So now beta can undertake a value of a to the power of 4 plus b to the power of 4 minus b times of a cube plus cb square divided by a b c times of c minus a. And as all of you know that in the original function I have substituted a as x, b as y, and c as z. So beta is actually now. Oh no. I need to leave it as k only. Sorry, it will always going to be k. I cannot assume any value associated to it. I'm sorry, I'm extremely sorry. Yeah, it will be k. So it will simply going to be k times of x to the power of 4 plus y to the power of 4 minus y times of x cube plus z y square divided by x y z times of z minus x. Okay, so now our function is p times of x y z, which is also satisfying commutative property, is it will basically going to be, since k and y minus x will always going to be common, I can take that out.